All right, let's look at correlation coefficients. Correlation coefficients. Good. A statistical measure which determines the amount of linear relationship between x and y is called coefficient of correlation. This shows the degree of correlation between the two variables x and y. It always shows the relationship between x and y. Okay, the coefficient of correlation is denoted R, and it is defined as the formula that we show on the screen now. Good. R is equal to square root of A prime. Now let's see on our next slide the formula for A. A simply means the slope of the regression line y on x, and A prime is the slope of the regression line x on y. Good. Now let's see what their formulas are. What you are seeing on the screen is the formula for the A, and here I have the formula for A prime. So both of them, when we substitute both formulas in that R, we're going to have this, and what we have on the screen right away is the formula. This becomes the formula. What I have there becomes the formula for coefficient of correlation. Good. Let's go. The coefficient of correlation. Now let's see an example very quickly. Example 1. We're simply going to apply the formula that we just saw now. Calculate the product moment correlation coefficient. That is still correlation coefficient or coefficient of correlation. They call it product moments. I said it in our last class. We can call it product moment correlation coefficient, and we can also call it Pearson's coefficient of correlation. Both of them simply mean the same thing. So let's see how we quickly calculate that using this table. We are given two variables for quantitative test score. We are going to call that variable x, and aptitude test score, we are going to call that variable y. So we are simply saying that this is my x and this is my variable y. And let's prepare a different table in our next slide, and let's see how that helps us to solve this question. Good. Let's see. Now we're going to prepare a table like this. All the values of x are on the vertical. Can you see that? On the vertical, that's the column. All the values of y for the other variable are also on that table too. If I find a column for x squared, if I square each of the values of x, I have x squared. That's the third column you are seeing there. And you can see our fourth column, we have xy, where we multiply x and y. Then we have the last column, y squared, where we have the square of each values of y. Let's see, and n will be equal to 10. We're going to apply the formula we established just few minutes ago. N equals to 10. Why is our n equals to 10? Because if you count the number of variables of x and y, if you count from the beginning to the end down the column, we have 10 variables, so n is equal to 10. So n represent number of variables that we have there. Okay, and remember, we are recalling our formula, and that's why we have r equals to what I have on the screen. So this formula becomes the formula for our correlation coefficient, and that is exactly what we are asked to do. So if I simplify all my values, remember this is my n is 10. The value of my n is equal to 10. Now that's the 10 I have here, the value of my n. Summation xy, that's the value I have here, xy, and that is what is substituted here. Okay. Summation y, summation x, which is this. Summation x is what I have on the screen there that I circled, and my summation y. Summation y is 45, and that is exactly what I've substituted. So we substitute each of the values. Then if I go to the denominator, my n is still 10, and that's what I have there now. N is 10, s summation of s squared 417. Everything else is on the table there. Summation of x, then squared, everything squared, that's 59 squared. Then we have n, this n as my 10 here, and summation y squared, everything is at the bottom of the table we have there. Summation y squared is 241, and summation y, which is lastly given as 45 squared. If I simplify all of this in the next slide, let's see what our numerator and denominator will give us after punching our calculator. Good. Let's see what we have. Okay, if I punch my calculator, I have that value. All we have to do is to simplify the numerator and denominator, and we have the value that we have on the screen, 0.9223. Okay, now if you check what we discussed in the early pages of this class, you discover that when you have a value that is very close to 1, then we say the two variables x and y are highly positively correlated. Highly positively correlated. And when we have a value that is very close to -1, we say the two variables x and y are highly negatively correlated. So let's check the pages of the slide. I gave some characteristics of R, correlation coefficient. So with this, I believe once we know this formula, you will be able to calculate the coefficient of correlation, or correlation coefficient. All right. Thank you for listening. Thank you.